Hello and welcome to the Docker session. This tutorial will incorporate following mentioned topics. However, for this session we'll focus on first four topics: how containerization approach came into existence, Docker architecture and its workflow, and we'll understand what are the basic terminologies of Docker. Now let's understand how containerization approach came into existence. Years ago, when there wasn't any virtualization or containerization technique evolved, applications were hosted on bare metal physical servers. Well, technically, one physical server was used for hosting one single application. In this approach, as shown in the figure, application, operating system, and hardware were tightly binded with each other. The main advantage of this approach was that the application can run effectively utilizing as much resource of the server it requires, whether it's RAM, storage, or CPU. However, it also had a couple of drawbacks in connection with the IT infrastructure, due to which we enter into virtualization world. So few of major drawbacks were: since we were using one server per application, it was quite expensive for procuring new servers. Multiple servers were required for hosting multiple applications. We need to assure the server should be kept in cool temperature. And finally, the administrative cost. So because of these disadvantages in IT infrastructure, a new technology came into existence which we call hardware virtualization. With hardware virtualization, we were able to create a multiple virtual machines on top of single physical server using hypervisor. This ultimately saved an ample unnecessary investment in the IT infrastructure, and now with the help of hypervisor we were able to run multiple applications on a single node. One of the major firms which provide virtualization is VMware. This approach led it to following benefits. Now we were able to run multiple virtual machines on single node, and with this we were able to run multiple applications on a single on a single server. Ultimately, this approach helped in saving cost in unnecessary investment for procuring multiple servers for each application. However, virtualization had also few drawbacks, like each virtual machine requires a dedicated operating system for running an application, which ultimately utilizes substantial storage capacity, RAM, CPU, etc. Virtual machines take some time to boot up. Since each virtual machine has its dedicated operating system, the licensing cost to OS increased. The cost of virtualization was also quite high. Apart from this, we should have a dedicated or trained engineers who were experienced in VMware or VirtualBox. And due to this drawback, and due to these drawbacks, containerization approach came into existence. Containerization is an approach to software development in which an application, service, its dependencies, and its configurations are packaged together as a container image. The architecture of this approach is somewhat similar to virtualization, but it has a major differences that containers virtualizes at OS level, whereas VM virtualize at hardware level. As you can see in the diagram, instead of hypervisor, which was responsible to create a virtual machines, now we have a container engine. Container engine is responsible for creating containers. For now, let's understand that a container represents an execution of single application, process, or a service. We will see in the depth what are containers, how container engine creates a container, and other relevant terminologies. One of the major firms that provides containerization approach is a Docker. Benefits of this approach are multiple containers can be run on a single OS. Containers are lightweight. We can boot up a container in very few seconds. And finally, containers, it utilizes very less hardware resources as compared to virtual machines. Now let's understand basic informations on containerization. Also, I could say let's understand basic Docker terminologies. Containerization is an approach to software development in which an application, service, its dependencies, and its configurations are packaged together as a container image. So, what is this container image? Container image is a package with all the dependencies and informations needed to create a container. This image includes all the dependencies such as frameworks, uh, plus deployment and execution configurations to be used by container runtime. Generally, an image derives from multiple base images that are layers stacked on the top of each other to form container's file system. An image is immutable once it has been created. We cannot change an image once it's created, though we can always create a new one and delete if previous one is not required. So what are containers? Containers are a running instance of container image. A container represents the execution of single application, process, or a service. It consists of the contents of a container image, an execution environment, and a standard set of instructions. Docker is one such containerization platform which packages your application and all its dependencies together in the form of containers so as to ensure that your application works perfectly in every environment, whether it's QA, UAT, or production. What is registry? Well, registry is a service that provides access to the repositories. The default registry for most public images is Docker Hub. A registry usually contains repositories from multiple teams. Companies often have private registries to store and manage images they have created. Repositories is a collection of related Docker images labeled with the tag that indicates an image version. Some repositories contain multiple variants of specific image, such as an image containing SDKs or only runtimes, etc. Those variants can be marked with tags. So, tag is nothing but a mark or label which you can apply to images so that different image or versions of the same image can be identified. Docker Hub is a public registry to upload images and work with them. What is a Docker file? Well, Docker file is a text file that contains the instructions or the steps for how to build a Docker image. Basically, this file is created by a developer. It's like a batch script. The first line states the base image to begin with, and then follow the instructions to install required programs, copy files, and so on until you get working environment you need. Finally, what is volumes? Well, volume offers a writable file system that a container can use. Basically, we use the volumes to persist the data. However, in depth, we'll understand how we used to work with volume later. Let's now quickly have a glance at Docker architecture. As you can see, this is a typical client-server architecture where client is nothing but your terminal, a CLI, a PowerShell or command prompt where you can run a command to perform certain operations like build images, pull image or run an image or uh, containers. This architecture encompasses three things: Docker client, Docker host, and registry. Docker host runs a Docker daemon. This Docker daemon is responsible for creating Docker images and containers. To create a Docker image, I will issue a Docker build command to Docker daemon in CLI. This Docker daemon is responsible for creating images based on inputs or the steps I have mentioned in Docker file and save it to either local or public registry like Docker Hub. If I do not want to create an image, since it's already available in registry like Docker Hub, I can pull that image issuing a Docker pull command to Docker daemon in CLI. Finally, if I want to create a running instance of my Docker image, I will issue a Docker run command to Docker daemon, which will create a container. In real-world software deployment process, developers or system admins may face an issue during the deployment in which the root cause can be wrong package or artifacts are being deployed or different versions of dependencies are installed in the server. This often creates a lot of headache during the deployment, especially if the deployment is in the production environment. Now let's quickly understand how Docker resolves this software deployment issue. Let's see a typical workflow of the Docker. Firstly, developer creates a Docker file which incorporates steps to create a Docker image. Docker image is Docker image is a package that has all the required application and its dependencies to run the application. When we run a Docker image, it creates a new instance which is nothing but a Docker container. Hence, Docker containers are nothing but runtime instances of Docker image. This image can also be stored in cloud repositories to which its registry provides access. Few examples of such registries are Docker Hub, Azure Container Registry, etc. There are substantial publicly available images in Docker Hub which can be pulled. We can also publish our own created image by providing private or public access. Now, since we can pull the same image on different environments to run an application using Docker containers, with this we can assure that the same artifacts or the same frameworks are deployed on every environment, whether it's QA, UAT or production, and our application will behave same in each of them. Hence, as we discussed, a real-world software deployment issue can be resolved with the help of Docker, since now every environment will have the same images. In the next session, we'll see the usage of Docker commands. Thank you all for watching this session. Please subscribe to this channel for getting notified for next video. Thank you.